Okay, in this video I wanted to finish up section 11.3. We're talking about quadratic functions, and at the moment we were looking at graphing quadratic functions. Problem 23 is just another example of sketching a graph. Of course, a quadratic function is a parabola, and so let's take a look at that one. Graph the function f of x equal negative x plus 2 squared plus 7. Okay, we've got to find the vertex, the intercepts, and whether the graph opens up or down. A is negative 1. Since that's a negative, I know that the parabola is going to open down. The vertex is represented by the point HK, and here's my my general formula here for vertex form. Okay, the way to look at this then is you got x minus negative 2, or that's x plus 2, same thing. H is negative 2, k is 7. Okay, so the vertex would be located at negative 2, 7, and you can plot that point on the graph there. And then we got to find the intercepts. Okay, so to get the x-intercepts, let y be 0, y and f of x mean the same thing, so you got to let the function be 0 and solve for x. I've already got that set up here. Let's add x plus 2 squared to both sides, and then take the square root of both sides, so we get rid of this power of 2. Of course, we need the plus minus when we take the square root of both sides, and then subtract 2. Negative 2 plus root 7 would be 0.65 roughly. And then negative 2 minus root 7 would be negative 4.65 roughly. Okay, so I can plot my two x-intercepts here. One of them is going to be at negative 4.65 roughly. That'd be about right here. Okay, and then 0.650, that'd be about right there. To get the y-intercept, I need to let x be 0. If I plug in 0 into the function, 2 squared is 4, although there'd be a negative in front of that. Negative 4 plus 7 is 3. Okay, so 0, 3 would be where the parabola crosses the y-axis, and I've got that point plotted. The domain and the range. Okay, so the domain of any quadratic function is all real numbers. I mentioned that in the last video. The range, okay, we can get that from the graph. It looks like if we are at 7 or less on the y-axis and we look to the left or to the right, we're going to be on the parabola. If we're bigger than 7, there's no graph that is above 7, okay, when you look up to the left or the right. So I'm going to say negative infinity to 7 using interval notation. Make sure you're including 7. Negative 2, 7 is like our start point here, and when we scan the y-axis. And let's go to problem 24 next. Recall that y equal ax squared plus bx plus c has a vertex v at the point xy, where x is negative b over 2a. Okay, find the vertex for each function, and then determine if that point is a maximum or minimum point on the graph. Well, let's see here. So I'm in this standard form, this ax squared plus bx plus c form. And for this problem, it looks like a is 1 and b is negative 2. So I want the opposite of b, that'd be 2, divided by 2a. 2 times 1 is 2. 2 over 2 is 1. And knowing that x is 1 means that we can get the y value by plugging 1 into the function. So that's what I'm doing here. 1 squared is 1, minus 2 is negative 1, minus 8 is negative 9. All right, so 1, negative 9 would be the vertex. Now this parabola is going to open up. Since a is a positive, I would know that. Now I'm not going to graph this, but I know that this parabola would open up. And so this point here, this vertex, would be the lowest point on the parabola. Okay, so I'd call that a minimum point on the graph. Here's another one, part B, f of x equal negative x squared plus 14x minus 76. All right, this parabola is going to open down since we've got a negative a value. Therefore, when we find the vertex for this problem, we're going to be finding the highest point on the graph. Okay, and we call that a max point. Let's compute that point. X is negative b over 2a, A for this problem is -1 and B is 14. So I need the opposite of B, that's -14, divided by 2A. 2 times -1 is -2. -14 over -2 is 7. And so then I've got to plug 7 into the function there. Let me do that now. Okay, so if I plug that in, 7 squared is 49. There'd be a negative in front of that, so -49 would be at the beginning. 14 times 7 is 98. Okay, so if I have -49 plus 98, that would be 49. And then minus 76 would be -27. Okay, so 7, -27, that would be the highest point on the parabola then. Okay, that'd be the vertex. Here's problem 25. Find the vertex for each function and determine if it's a maximum or minimum point on the graph. Okay, now, same idea, but the plan is going to be different. You see, I was in standard form here in the last problem for these two functions. I'm in vertex form, and so I can get the vertex right away, right? Like I don't need to compute -b over 2a like I was doing up here. Just identify what is h and what is k and give the answer. Now, for this first one, a is 1. That's a positive, so I know the parabola would be opening up. So the vertex would be the lowest point then on the graph. If the parabola opens up, this would be a min point. And x minus -3, that's the same as x plus 3. So h would be -3. K would be -19. -3, -19, as I said, that'd be the lowest point on the graph. All right, here's another one. We've got a parabola that's going to open down. Since a is a negative number here, a is -3, the parabola opens down. So this vertex is going to be the highest point on the graph, or it'd be a max point. H would be h would be 2, and k would be 5. Okay, so the point V equals 2, 5. That'd be the highest point on the graph. By the way, note that -3 had nothing to do with getting V. Okay, that just tells me that the parabola opened down, and I could indicate that it was a max point then. There's a couple of application problems mixed into this at the end, so I thought we'd take a look at maybe 2 of them here to finish things off. Problem 26. If an astronaut on the moon throws a rock upward with an initial velocity of 78 feet per second, then the height of the rock, which is in feet, after t seconds is given by this function here. Okay, part A, how high is the rock after 1 second? T is the time, which is in seconds, so that's just going to be a plug it in and simplify. Okay, and if I plug in 1 for t, I got -2.6 plus 78 plus 5, that's going to give me 80.4 feet. So at 1 second, the rock is going to be at a height of 80.4 feet above the ground. Okay, part B, determine the time at which the rock reaches its maximum height, and then find the maximum height of the rock in feet. Maximum is a key word, okay, because basically in this problem, they want us to see that we would be working with a parabola. Okay, I've got a quadratic function, so I know I'm going to be working with a parabola. A quadratic is always a parabola. This parabola would be opening down. Now, I'm not going to graph this parabola, but I know it'd be opening down. And by the way, that would make total sense to us why we would have a parabola opening down. If you were to throw a rock up in the air, it's going to go up, reach a peak, and then fall back to the ground, right? And it's going to create an arc-like shape, and take on the shape of a parabola. So it makes sense to be working with a parabola, in a problem like this. We want to find the maximum height of the rock. Well, the maximum point on this parabola would be the vertex. So to me, this is like just an exercise in finding V. All we need to do is find V, and we're practically done at that point. Let's do that now. Okay, so we're in standard form here, right? So we need to find the point -b over 2a for x. A is negative 2.6, B is 78. So I want the opposite of B divided by 2A. Negative 78 divided by negative 5.2, that'd be 15. So at 15 seconds, the rock is going to be at its highest point in the air. To find that height, I would just plug 15 then into the function where I see t. And so I've done that. Okay. If you were to then go to the calculator and type this in, I'm getting 590 feet coming out of that. So the vertex, the highest point on the graph, would be located at 15,590. Now they're asking for two things here. They want to know the time to the max height, and they also want to know the max height, which is in feet. Well, t is the time, right, and t is my input here into the function. So it looks like it's going to take 15 seconds for the rock to be at its highest point in the air. At 15 seconds, the rock will be at exactly 590 feet, and then it's going to be heading back to the ground after that. Okay, so maximum is a key word. When you see the word maximum or minimum, think vertex, okay, because it's really, the problems at the end of this section are really just an exercise in finding the vertex is all. Okay, and we'll take a look at, here's one more example in the section. Problem 27, a farmer decides to enclose a rectangular garden using the side of a barn as one side of the rectangle. He has 80 feet of fencing. Suppose that X represents the length of each of the two parallel pieces of fencing, and Y represents the length of the remaining piece of fencing. So I've got a picture shown there. He's not going to put any fence along the barn. He's just going to use that side of the barn as enclosure. Part A, determine a function A that represents the total area of the enclosed region. Well, he's building a rectangle, and we know the area of a rectangle is length times width. So I'm creating a function of x. I'm going to call that a of x. Length times width means I've got x times y. Now here's the thing. I'm building a function of x. So I don't want x and y floating around. I'd like to have only x. We're told in the problem that he's only got 80 feet of fencing. Okay, so if you take x plus y, that's 80 feet. Or 2x plus y equal 80. If you subtract 2x, y would be negative 2x plus 80. So that would be the remaining side here in terms of x. Now I'm taking x times y, and I said I don't want x and y floating around. I'd like to have only x. Well, I know what y is in terms of x, right? I just figured that out up here. So where I see y, let me go ahead and replace that with negative 2x plus 80. That way everything is going to be in terms of x. When I distribute x into these two terms, negative 2x squared plus 80x, that would be the function that we would circle here that, that'd be modeling this situation. Okay, part B, what dimensions of the garden will produce the maximum area? And then what is the maximum area that can be enclosed? Well, so how should he design this so that the biggest possible rectangle can be formed? He's only got 80 feet of fencing, so should it be like longer, like left to right type deal, or maybe have it be more jetting out in the field, or should it be a square? Like how exactly should he build this so that he can have the biggest rectangle possible? Well, maximum is a key word. Okay, so the thing to see here is that this function, this formula that we've created, is a parabola, right? I'm working with a quadratic. In other words, I'm in the form ax squared plus bx plus c. C is 0, that's okay. A, b, and c can be any numbers, just don't let a be 0. So I've got a parabola that's going to open down because of that negative in front of the squared term. Maximize the area. Okay, well, if I find the maximum point on this parabola, that would be the vertex, right? I know I'm working with a parabola that opens down, and this is just another exercise in finding the vertex. So that's what I'm doing here next. Okay, I'm going to calculate x by taking negative b over 2a. A is negative 2, b is 80. So I want the opposite of b, that's negative 80, divided by 2a. 2 times negative 2 is negative 4. Negative 80 over negative 4 is 20. Okay, and then to get the area, or I guess they're asking for the dimensions here, y is negative 2x plus 80. Well, x is 20, right? We've already said that. So if you take negative 2 times 20, that's negative 40, plus 80 would be 40. Okay, he would want to go with these dimensions then, 20 feet by 40 feet. And 20 times 40 is 800 square feet. You could also plug 20 into this function here that is just in terms of x. And I guess I've plugged it into the unsimplified form. Okay, negative 2 times 20 is negative 40, plus 80 is 40. 40 times 20, well, that's the same as x times y, right? 800 square feet. Okay, so he's only got 80 feet of fencing to work with. He would want to design this so that x is 20 feet and y is 40 feet. If he goes with any other dimensions, the rectangle is not going to be as big as it could have been. Okay, in other words, he's going to get an area that is something less than 800 square feet. Okay. Again, to me, with a problem like this, it's just finding the vertex. Okay, that's the thing to see. You've got a parabola facing down. We want to find the max point on the parabola. We're not graphing the parabola, right? But that's we just like to know the max point. And at that point, we're practically done with the problem. Okay, so if I were to have graphed the parabola, I'm not going to do that, but if I were to do that, 2800 would be the vertex. Okay, that'd be the highest point on the graph. All right, so at this point, we are now done with 11.3. The homework is on page 888. Be sure to look at the odd number problems there for me.